So another solution concept for games is the Pareto-optimal solution, named after Wilfrido Pareto from the 1800s, and it's also known so generally referred to in especially in economic text as an efficient solution. And it's simple. It just says that a Pareto solution is a solution such that there is no other solution where at least one agent does better and nobody does worse. So S is a strategy for everybody, and it's Pareto if there is no other one. If this is Pareto, if there is no other solution where at least one agent does better and nobody does worse. So let's look at this one over here. The way you find Pareto solutions is just by checking every single box, pretty much. So you look at, let's start here, this one, 1, 2. So Alice gets utility of 1, Bob gets a utility of 2. So we say, well, is there some other strategy instead of, this is BD, is there some other strategy or some other box where one of them does better and nobody does worse? Well, yes, right here, 2, 2. So this one, 2, 2, Alice does better, Bob does the same, so he doesn't do any worse. So this is not Pareto solution. Is 2, 2 a Pareto solution? Well, is there another one where one does better and nobody does worse? Well, if you move over here, you see that, in AC, Bob does better. He goes from 2 to 3. But Alice, she goes down to 1, so no. Similarly over here, one does better, but the other one does do worse, so no. So yes, bingo, this is a Pareto solution. How about this one? Is there another solution where at least one agent does better and nobody does worse? No. Yeah, you can check it over here. If you go over here, one of them does worse. If you go over here, one of them does worse. So this is also Pareto, and also this one's Pareto. So that's what usually happens with Pareto solutions. You have many solutions. So Pareto, many solutions are possible. There is, of course, always going to be one, right? So there's always going to be at least one solution. But more generally, many solutions are possible, like in this case. And so it might be hard if you have multiple solutions to agree on, okay, which Pareto solution do we want? But generally, like I said, these are what we call efficient solutions, and a lot of the problems are actually, you start out with, the set of all possible solutions, and you get rid of all the non-Pareto solutions because they're not efficient. Because why would you be here when you could be here, right? Why would we choose this solution when we could choose that solution? So a lot of the problems are actually, choosing between Pareto options. So that turns out to be the actual problem. So choosing between the various Pareto solutions, because the other ones are clearly not good enough for us, because we could choose the other one. And the third problem is, but if you look at the Pareto solutions, they are not stable. So let's look like in this one here. If, say, we agreed on a C, right? Agent, in this case, Bob. No, Bob will go from 3 to 2. Alice. So if you are at A3 in this one, AC, Alice, she's getting 1. She might think, okay, that's fine, but I could just play B. If Bob's gonna play C, should just play B. That way I get 3. Yeah, he's gonna get 1. But hey, we're in a Pareto solution also, so I could get, and I'm doing better for myself, right? So that's a problem, right? So Pareto solutions are not stable. Like in this case, we ended up going from one Pareto to another one. That's not always the case. If we're here at 3, 1 also, Bob is going to say, well, look, Alice is playing B, and I'm getting 1. If I played D instead of C, I'm going to get 2, right? So Bob has no incentive at this Pareto solution, BC, or 3, 1. Bob has no incentive to stay there, right? He's like, she's going to play B. I'm definitely going to play D. We're going to move over here, which is not a Pareto solution, is not efficient. And really after that, we should move over here. And so you can see the problem. Things don't stabilize. So that's another problem with the Pareto solutions.